parabolas, you start them in Math 1. You've been doing them in every class that you've had probably since. You've looked at parabolas a lot of different ways. Maybe expanded form, like your y equals ax squared plus bx plus c. That's used for quadratic formula a lot. We've factored them. We have probably looked at them in vertex form. I think that we do that in Math 2. So we've done a lot of stuff, but have you guys ever seen a parabola turned on its side like this? Okay, Trevin says yes. Okay, some of you have, some of you no. And so these parabolas, they are going to be different because for these parabolas, they are not functions. The x is a single variable, and then the y will be squared for these parabolas. Okay, basically like the x and the y have been switched here. So, so we should be pretty familiar with the standard parabola where we have y equals a number and they either open upward or downward. And what we're really going to be concerned with is looking at the parabolas in vertex form, which is going to be a times x minus h squared plus k. And in vertex form, we know that this is sort of like we've dealt with whenever we're shifting things. So this is going to be moved to the right h, up k. So we'll have a vertex of hk. For a parabola, we are going to have a focus, an axis of symmetry, and a directrix, and then you have to be able to tell the opening either opens upward or opens downward. So that focus, axis of symmetry, and directrix are those three characteristics that we have to know. If we look at this, here, the focus is going to be a point somewhere inside of the parabola here. It will be on the axis of symmetry. So this is the focus. And then the axis of symmetry is the line that goes down through the center. Thank you. So that is your axis of symmetry. Okay. That word focus is the same as for an ellipse. There's just one of them, though, so we call it focus instead of foci. And we could go into great detail on exactly how you would draw a parabola, but we're really short on time. You also will have a line called a directrix, and the directrix will be on the outside of the parabola. This is your directrix. Whenever we look at this, we have this value that you see right here, P, and it's 1 over 4A. See, where'd my formula sheets go? Here they are. You might be on your formula sheet. I might should just change it here too. It says absolute value of A equals 1 over 4C for the formula sheet. If that were the case, then I should change this letter right here to a C, and I should probably change those so that they'll align. Our book uses an A right here, and when we get into doing this, you'll see what this means a little bit more. But that P value right there, the distance from the vertex to the focus is going to be P, and the distance from the vertex to the directrix is also P. So we go up or down P for those. If the parabola opens left or right, your focus is still on the inside, so this would be your focus. And then your directrix is this line on the outside. course, the line of axis of symmetry is that line that you could fold the parabola in half for. Okay. Questions? I think it kind of makes more sense once we start doing problems. This is, well, let's see. Wonder if this right here still works. Let me see real quick. If it does, I'll show you real quick what a parabola looks like, if this still works. Okay, so, which one is it? I need to make this. Alright, so a parabola, it says, is defined as the set of points equidistant from a point and a line. That point is called the focus, the line is the directrix. So to kind of give you a really, really quick view of what this looks like. So right here is my focus, here is my directrix. So anytime I move this on the point here, that you can see these two dotted red lines are the same length. So it has to be, all of the points on the parabola have to be the same distance from the focus and from the directrix here. So that's kind of what those are. We're not going to go into great detail on anything more than that, but that's what those are. For example 1, we're going to find the vertex, focus, directrix, and axis of symmetry. And so this one is already in vertex form, and it is an x equals equation. So if it is an x equals equation, does it open up and down or left or right? Left or right. And so when we have a parabola that opens left or right, opening to the right is the positive direction, and opening to the left is the negative direction, whereas we have, whenever it opens up for a normal parabola, that means our x squared is positive. Whenever it opens down, that means our x squared is negative. So here we're going to look at our y. It's not multiplied all the way out, but y right here is going to be positive. You're going to square it, and then you're going to multiply it by positive 2. So your y squared is positive, so our parabola is going to be a parabola that opens to the right. And so for a parabola, the first thing you want to find is the vertex. And it's a little bit tricky with this one when they open left or right. We're looking for this vertex right here. So I want to say that the point is 4, 3. But that would be incorrect because this 4 right here goes with the y, which means it's our y coordinate. So since it's with our y, it's inside the parentheses, we use the opposite sign. That's our y coordinate for our 4. Okay? The 3 is the x coordinate. It is not in the parentheses, so we do not change its sign. It's going to be a positive 3 there. Okay. So, questions on vertex? Alright, the way we find the focus and the directrix is that we have to know that p-value, or on your formula sheet it says focal length, and it says absolute value of A equals 1 over 4c. If you're using that, it's 1 over 4 times this number right here. This would be your C. So we're going to say 1 over 4 times 2, which is 1/8. And what that tells us is the distance from this point right here, which is 3, 4. The distance from 3, 4 over to the focus is going to be 1/8. So if I am going from the vertex over here to the focus, which coordinate is going to change, the x coordinate or the y coordinate? It's going to be x, because right here this is our x coordinate. So we would have, in this case, our focus, we would have at 3 and 1/8, 4. Or they might do improper fraction here, so that would be 25 over 8 and 4. Typically, in upper level math, we don't use mixed numbers because 3 and 1/8 can look a lot like 31 over 8 or 1 over 38 or 3 times 1/8. That can, depending on what you do, especially, you definitely don't want to write 3 and 1/8 like this and use the slanted, because then it really looks like 31 over 8. So we're more likely to see 25 over 8 as far as our actual answer, but it will, either one I'll take if it's one where you write the answer in. Okay, and then the directrix. Okay, for the directrix is going to be the line over here, and the distance from it to the vertex is going to be 1/8. So this time we've got to go to the left 1/8. And so we would take that x coordinate and we would subtract 1/8, which would give us 2 and 7/8. But the directrix is the equation of the line. Is this line vertical or horizontal? Vertical. Vertical lines have an equation of x equals a number. So our directrix is going to be x equals 2 and 7/8. Or you might see it x equals 23 over 8. Okay. Questions on that part? And then the last thing it asks for is axis of symmetry. Axis of symmetry would be this line right here. That is a horizontal line. I'm just going to write AOS for axis of symmetry. That is a horizontal line. Horizontal lines have an equation of y equals a number. What number is that going to be? It's going to be 4, because it passes through that vertex right there. The y coordinate is 4, so it's going to be y equals 4 for your axis of symmetry. Okay, questions? Okay, here's our next one. We have to write y equals 2x squared minus 8x plus 5 in vertex form, and then find the vertex, focus, directrix, and axis of symmetry. So this one's not written in vertex form for us. We have to put it in vertex form. In a little bit of a way, it's going to be like the circles and ellipses, but it's a little bit different because our x and y's are not squared. Plus, we don't want this to have the x and y's on the same side. We want it to stay y equals something. Okay, so we are going to complete the square. What we're going to do is we're going to kind of leave out this 5 over here. I could move it to the other side, but I'm just going to kind of leave it out. So I'm going to factor the 2 out, but only out of the first 2 terms. So I'll have 2x squared minus 4x plus blank plus 5. And I could, if I wanted, put a plus blank over here on the other side. Or I can put a minus blank here. Because if I add a number to this side and then I subtract a number from this side, then those two will cancel each other out. Typically with parabolas, it's a little easier to work all on one side instead of working on both sides. So we add a number here, we have to subtract a number here. Okay, so we'll have y equals 2, and then we're going to complete the square here. So x minus 2 squared, I'm going to divide that 4 by 2, I get 2. Then I got to square the 2, and I get a 4 to put in this blank right here. Okay, what number goes in the blank on the end? 8. Why not 4? got this number you factored out right here. So you'll have an 8 right there. Instead, you got to do 4 times 2, which is 8. So we've got minus 8. So now our parabola is in vertex form. Okay, questions? Oh, yes, thank you. Thank you. Oh, it is not negative 8. It is negative 3 because I got to combine my 5 and my 8 there. Does that look better? Okay, so our vertex. All right, Trevin, what would the vertex be for this one? Perfect. 2, negative 3. Notice Trevin did not do the opposite sign for that y coordinate right there because it's not in the parentheses, so you don't do the opposite sign. The x that is in the parentheses, so you do opposite sign. Okay. Tell me, Richard, does this parabola open up, down, left, or right? It is up. Yes, very good. And we know that because, first of all, it's a y equals, which tells us it's either up or down. And then we know it opens upward if our x squared is positive, and it was here. So this one opens upward. And we just found the vertexes right here at 2, negative 3. So we've got to find our focal length again. So that is our absolute value of A equals 1 over 4c. That c is this number right here, so 1 over 4 times 2. I should have used a little bit. I promise it's not always 1/8, but it has been on both of these problems. So this time, it's going to be a little different than the last problem that we did because the focus has to be up here and the directrix has to be down here. So we're not moving to the left or to the right, we're moving up or down this time. That's why I always like to draw myself a picture whenever I'm doing this so I can see where it lines up and I know which variable to change. So for our focus, okay, a focus is a point. I've got to go up 1/8. So, Boone, if this point is at 2, negative 3, what are the coordinates of my focus going to be? It's going to be 2. It's not going to be... So we got to go up from negative 3. We got to go up 1/8. So what's that going to give us? Yes, negative 2 and 7/8. Very good. That one is a little bit confusing because it seems like you're subtracting, but you're really adding. But negative 2 and 7/8 is a little higher than negative 3. So you're just taking negative 3 and adding 1/8 to it. You might see that as an improper fraction. We'll just leave it. It's fine. Okay. So the directrix. The directrix is going to be the opposite direction, so we've got to go from the vertex, we've got to go down 1/8. And Jacqueline, for our directrix here is a horizontal line. So what kind of line do we have? Is it an x equals or a y equals? It's y equals. And that's so confusing, and even in pre-cal and calculus, and sometimes Miss Hyatt, we all still get that mixed up, but y equals is our horizontal line. So if y equals, we're going to have the y coordinate here. So if we were at negative 3 and we went down 1/8, what will we get for that, Jacqueline? Very good, negative 3 and 1/8. So y equals negative 3 and 1/8 is your directrix. And then the last thing it asks us for is our axis of symmetry. So our axis of symmetry is this line where we could fold the parabola in half. It is vertical, so axis of symmetry. Lapita, for a vertical line, is that x equals a number or y equals a number? backwards from what it seems like it should be, because your y-axis is vertical, but it's x equals a number for your line. So you're going to have x equals a number. And we know this axis of symmetry passes through the vertex where our coordinate is 2, -3. So what is the x value? What is the x for that line? If it goes through this point, which is at 2, -3, then it has to have the same x as the x coordinate, right? So we would have x equals our 2 here. Okay, questions on that one? Okay, so example 3 says write x equals y squared minus 12y plus 4 in vertex form and find vertex, focus, directrix, and axis of symmetry. So for this one, Brady, is this going to be one that opens up, down, left, or right? It is going to be to the right. That is correct. And we know it's to the right because it is an x. We know it's either right or left because it's an x equals. We know it's to the right because our y squared is positive. Good. All right, so we've got to put this in vertex form before we can really figure anything else out. So this time, whenever we do this, there's no number to factor out for your y. So we're going to have y squared minus 12y plus blank. Plus 4, and then I'm going to put me a minus blank over here. If I add something and then subtract that same number, then they'll cancel out. So, Richard, when we complete the square on this, what number will we get right down here in the parentheses? Very good. And so what number goes here? Very good. We just square that 6 and get a 36. What number goes over here? Also 36, because there's no number to multiply by out here. If there was a number, we'd have to multiply there, but we don't. So 4 minus 36 is going to give us negative 32. And there is no number out here, and sometimes that messes everybody up. So if you need to, put your 1 right there. Okay, that C value we're going to need later, it is a 1 since there's nothing out front. Okay, so we need vertex. Spencer, what's the vertex for this one? Very good. And I like the way Spencer did that because I always want to say 6 negative 32, just like it's a y equals equation. But this is your y coordinate, so there's your 6. This is your x. And so the vertex here would be at negative 32. All right, we've got to find that focal length for this. That's where we use that formula sheet. And so that focal length, Sadie, how are we going to find the focal length for this one? Mm-hmm. 1 over 4, that part stays the same, and then what number would we multiply it by here? It is the number in front of your parentheses. So the C, whenever you look at that formula that says 1 over 4C, that number right there in front of your parentheses, that's your C, once you've got it in vertex form. So in this case, just a 1. Okay, so this time we get 1/4 as our focal length. So that means we need to go to the right 1/4, and that'll give us the focus, and we need to go to the left 1/4, and that'll give us the directrix. So for our focus, Sadie, if our vertex is at negative 32.6, what are the coordinates of our focus going to be? right here's our coordinates, negative 32, 6. And we've got to go over to the right 1/4. If we change our, if we move to the right, is that going to change the x coordinate or the y coordinate of that vertex? It's going to change the x, because x tells us how far to go horizontally, right? So what we're going to do here is we're going to take that x coordinate, negative 32. We're going to add 1/4, which you can do in your calculator, or negative, that's going to be negative 31 3/4 there. So our focus is going to be at negative 31 3/4. The y coordinate stays the same because it doesn't move up or down. It stays right there. So that will be our focus. The directrix, we're going to do pretty much the same thing, except for it's going to be a line instead of a point. So Jade, for the directrix, we've got a vertical line for our directrix here. Is that going to be x equals a number or y equals a number for the equation? We have a vertical line. It's x. X equals a number is a vertical line. And so what will the x coordinate be over here for that directrix? Negative 32 1/4, because we have to take negative 32 and subtract 1/4 from it. Okay, questions there? Our last part is we need the axis of symmetry, which is a horizontal line. So our axis of symmetry is going to be a horizontal line. Richard, is a horizontal line, is that x equals a number or y equals a number? Y. So y equals, and it goes through this, it goes through the vertex here. So we look at the y coordinate, so it's y equals 6 in that case. Okay, questions? Okay, I want to get through at least the next one because it's a little bit weird, and you'll see one like this. Okay, so write y squared minus 4 times x minus 3 in vertex form and find the vertex focus directrix and axis of symmetry. Okay, I won't make you answer the whole thing. Is this one that opens up and down or left or right? This one's confusing because it's kind of solved for y, but the y is also squared. So you're looking at what's squared. So if the y is squared, that means we need to solve this for x. So this one is one that's going to either open to the left or to the right. Okay, let's get it solved for y or for x first before we can really tell whether it's left or right. Okay, so you have to solve this one because the x is not squared. You've got to solve for x here. So to do that, we've got y squared equals negative 4 times x minus 3. And so we could distribute that negative 4. So we get y squared equals negative 4x plus 12. We could, now we're trying to get that x right there by itself. So next we would need to subtract 12 from both sides. So y squared minus 12 would equal negative 4x. And then last, we would divide everything by negative 4. And because I don't want to have a fraction, or I don't want to have like a y squared over negative 4, I'm going to make this negative 1/4 y squared, because it's not written there, but there's a 1 in front of that y squared, plus 3 equals x. I also don't like that x on that side, so I'm going to write x equals negative 1/4 y squared plus 3. Now there are times you would have to continue. But this is in vertex form because there is no y anywhere that you need to complete the square for. So if you need to think of it like this, what you really have here is y minus 0 squared plus 3. Or plus 0 squared plus 3. So for this, we've got the negative 1/4 out front. I'm going to run through this fairly quickly. So our vertex, I was already wanting to say 0, 3. But that would be wrong because 0 is with the y. So it has to be our y coordinate. The 3 is our x coordinate. I guess I should also sort of sketch me a graph here before I try to do my vertex, for my focus and directrix and all of those things. So for this one, let's see, Elena, does this one open left or right? When you're talking left or right, your positive direction is right. So if it's positive, it's right. If it's negative, it's left. So which one would it be for this one? What number do we have here in front of our y square? Left, yes. Yeah, always get it in vertex form before you answer that question, okay? So don't look at the original equation. Look at what it is in vertex form. So it's going to be to the left. We have the point 3, 0 here. So we've got to find that focal length. That's the absolute value of A equals 1 over 4C. Our C this time is negative 1/4, which looks kind of ugly here, but it's actually going to be nice over here because what is 4 times negative 1/4? It'd just be negative 1. If you need to, 4 over 1 times negative 1 over 4 gives you negative 4 over 4, which is negative 1. So this is just negative 1. Or actually, it's absolute value, so don't worry about that negative. Just make it 1 because it's going to match. We don't really care about the sign. We just know we're going to have to go left or right. So our focal length this time is 1, which makes it a lot easier. You don't have to deal with fractions. So for the focus, which is going to be over here to the left, we've got to subtract 1 from our x-coordinate. So our focus is at 2, 0. For our directrix, we have a vertical line, so that's x equals a number. And we would have to add 1 to our x-coordinate, so we'll get x equals 4 for our directrix. And then the last part would be that axis of symmetry. It is a horizontal line, so that's y equals a number. And it's going to be y equals, and then it's going to equal the y coordinate, so it's 0. Alright, and we did not get to those x and y intercepts. Let me look in the book real quick and see. I'm not going to make you graph any. Let me look in the book and see if that is something you got to do anyway. I don't know if it is. Let's see, 13 through 21. No, you can still do this homework because it doesn't ask for x and y intercepts. X and y intercepts is kind of a little extra thing I want us to do there, but we might just skip it this time. So you can do that homework. You do not have to graph any of them. I do suggest you graphing like a really, really bad graph like I am, just to see which side your focus is on, left or right. But you don't have to graph it in any type of form. And actually, I just remembered that quiz pulls from a question bank. So Adam's quiz won't be the exact same as any of your quizzes. So I'm just going to go ahead and open it right now so you can see what you missed. If you have any questions, I'll be here Monday. Please come by and see me. now.
It's a good thing I started now because I have plenty of time to get mine.
Yeah, that's fine. We'll try for next week, hopefully. Yep. Okay. I need to open that. No, I think everybody goes to third right now, and then first lunch is in the middle. Have a good weekend, Sadie.